Can you solve this Math Olympiad problem we have on the board? If you think you can, pause the video and make a guess. I'm still your friend, Maths with Exponential. Let's solve 2 power x plus 4 power x plus 8 power x is equal to 39. For us to solve this, we are going to apply a little trick. Remember, we have the first term to be what? We have the first term to be 2 power x, then plus the next term is 4. 4, I can write it as 2 times 2, which is 2 squared. So write it as 2 squared, then raised to already existing power, x, then plus 8 can be seen as 2 times 2 times 2, which is 2 power 3. So write it as 2 power 3, already existing power, x, and that's what? 39. Okay? But one thing you have to recall is one of the laws of exponent. In that law, it states that whenever you have a raised to power m, n, that we can take it as a raised to power n raised to power m. That is commutative property of multiplication. Whatever we are multiplying in the same power, we can actually flip their positions and nothing changed. So here we can rewrite this to be 2 power x plus 2 power x all squared. I just applied this particular rule, just changing the position because nothing changed. 2 times x is the same thing as x times 2. So you have it as plus, same thing is applied here, 2 power x raised to the power of 3 equal to 39. Okay, this is what we have at this point. So at this point, we observe one common thread here. 2 power x, 2 power x, 2 power x. So let's define a term. So I can say let y be equal to 2 power x. Let y represent 2 power x. So I can now have it to be that y plus y squared plus y cubed is equal to 39. Okay? So this is what we have, since immediately we replace the values of 2 power x to be y. So the next thing we do is to subtract 39 from both sides. So if you subtract, what do we have? We'll be having it that y plus y squared plus y cubed minus 39 is equals to 0. In this place, you can see we have clearly a cubic function because the highest power of the unknown is what? 3. Good. So what do we do? 39, look at the order. Power 1, linear function, quadratic function, cubic function. But this particular 39 can also be in that form because we can write 27 plus 9 plus 3 is also 39. And you know that 27 is 3 squared, 9 is 3 cubed, and 3 is what? 3 in power 1. So we can replace it to be that form. We have it at y plus y cubed, y squared, plus y cubed. Then since we have minus 27 minus 9 minus 3 is equals to 0, right? So let's rewrite it. We can now still write this particular expression again to be that y plus y squared plus y cubed minus 3 cubed, as I said earlier, for 27 minus 3 squared for 9 minus 3 is equals to 0. So on getting to this, what do you observe? We will now pair those ones that are common. So we have it as y minus 3 to be the first one. I'll pair it plus, I'll go to the next one, y squared minus 3 squared. I will pair it to be my second one, plus y cubed minus 3 cubed. I'll pair it to be my third one, and that's still 0. Nothing changed. So here, what do we observe? We can perform a simple, what do we call it? We perform a simple identity. We know one of the identities, this is a square and this is a square, we have a minus. And in difference of two squares, we have a particular rule. which says that rule says that a squared minus b squared is the same thing as a plus b into a minus b. Okay, this identity will serve for the difference of two squares. We also have another identity which says that when we have a cubed, the identity says that when we have a cubed minus b cubed, that is the same thing as a minus b into another bracket of a squared plus ab plus b squared. This is how the identity is. So we apply it here, and that's all. So what do we notice? So if you're applying these identities, you can now see that y minus 3 plus, we have a unique term here again. So in difference of two squares, my a will now be y and my b will now be 3. So we'll write it using difference of two squares, and that will give us what? That y plus 3 into y minus 3. Okay, this is for difference of two squares. Then for the second one, we have it to be plus, we have the next one which is y minus 3. We have it as y minus 3 into already existing bracket, which is y is now the first term, which is y squared plus, what do we have next? 3 times y, which is 3y. What do we have next? Plus 3 squared, and that's equals to 0. Observe that y minus 3, y minus 3, y minus 3 in each term. So we can factor it out. Okay? So if I factor out y minus 3, remember the first term is now, you'll now see I'm having, if you factor y minus 3 from the first term, you're having 1. Then plus, what is left here, I will now be left with y plus 3. Okay? Then if I factor out y minus 3, I will now be having plus, I'll be having y squared plus 3y plus 3 squared is 9, and that's 0. I will now have y minus 3 in a bracket. What is left here? Let's collect like terms. Since they are adding, no multiplying. Let's collect like terms. What do we have? The first highest power is squared. So y squared is just 1 here. So you have it as y squared. Then the next thing we see is the linear term. 3y plus y is what? 4y. Then the numbers, 1 plus 3 is 4. 4 plus 9 is 13 plus 13, and that's equals to 0. What do we have? When two terms multiplies to get 0, that means one of them is 0 or both are zeros. So for the first term, y minus 3 is equals to 0. That means that y is equals to, we are adding 3 to both sides. Y is equals to 3. So our first term is that y is 3. Then for our second term, we are having a quadratic term, which is y squared plus 4y plus 13 is 0. This is a quadratic term multiplies to get 13 but adds to get 4. So we use a general quadratic formula which says that y will be equals to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Okay? So our a is the coefficient of x squared, our b is the coefficient, our a is the coefficient of the quadratic term, b is the middle term, and the last term is c. So what do we have? We have that y will be equals to minus b is 4, minus 4 plus or minus the square root of 4 squared minus 4 times 1 times 13 divided by 2 times 1. Okay? This will give us that y is equals to minus 4 plus or minus the square root of 4 squared is 16 minus 4 times 1 is 4, 4 times 13 is 4 times 3 is 12, 4 times 4, you have it as 52 divided by 2. This will also give us what? You have it as 16 minus 52 will be, we have minus 4 plus or minus the square root of minus 36 divided by 2. Okay? So at this point, what do we have? We'll now see that the number in the square root, we have it to be minus 4 plus or minus the square root of 36 times the square root of minus 1 divided by 2. Okay? So here it is giving us a complex solution. That means y is equals to minus 4, this plus or minus square root of 36 is 6, square root of minus 1 is I, divided by 2. So 2 can divide to have 1, 2 will divide to get 2, 2 will divide to get 3. So you see that y is equals to minus 2 plus or minus 3i. Okay? But if you look vividly well, you can see that we actually defined our y to be equals to what? 2 power x. So since this particular term is having a complex solution, we are not going to take this. So this is not, there is no real solution. So this is actually out. We only take when the real solution is only when y is 3. The value of y when it's 3. You see that y is equals to 3, and we also know that y is equals to 2 power x. So what do? We substitute 2 power x must be 3. These two numbers cannot be expressed in common base, so what we do is that we take the logs. So if you take the logs of both sides, you have it that log of 2 power x is equals to log of 3. Okay? So you remember that when you have log m power n is the same thing as n log m. Yeah. So since this is possible, that means these two can multiply, x can multiply 2 log. X log 2 is equals to log 3. Then the next thing we do is to divide by log 2 and divide by log 2. If you divide by log 2, x is equals to log 3 over log 2. Okay? So if you have this, there's one law of change of base that when you have log m divided by log n, that the answer will be log of base n of m. Okay? So if you apply it here, you can see that our x, that x you are looking for, x will be equals to log of base 2 of 3. And that's the answer. Do well to like, share, and comment. See you next time.